Hello, I'm Eric Snodgrass, and thank you for watching today's Ag Forecast brought to you by Nutrien Ag Solutions. I want to start off first with a couple of pictures here taken by Karen Braun. She's one of my favorite follows on Twitter. It's at KANNBWX. That's where you can kind of see her stuff. And she's doing normally what she does this time of year, which is this crop watch. And she took a couple pictures here I found interesting in South Dakota and Minnesota. It's what the corn looks like. And what I found interesting was the way it was kind of just blown over to the side. And I heard some reports from folks in the Northern Plains and Upper Midwest about how windy things have been. So I thought I would just confirm what you've been experiencing here. This is a map that's looking at the last 30 days at surface wind speed anomalies, so differences from normal. And we kind of look right into this area here. We have had some very strong winds. Places here averaging over the last 30 days 5 to 10 miles an hour above normal. And that's hard to do. So that's a substantially windy pattern. And with the high wind conditions, even when rain does come in, you can very quickly evaporate it, especially if you have some high heat. And I think we need to talk about what's going on in the soil moisture so that we have a clear picture of how things are going to evolve here in the near term. Because we have a pretty interesting kind of model battle to discuss, and it's going to be kind of fighting over how the moisture returns to this map. It's the top 10 centimeters of soil moisture. We're looking here again at percent. And in the top 4 inches, we do notice that there's a substantial portion here of the upper Midwest and Northern Plains that's very dry. The grounds are saturated farther to the south, as you can see here, and we don't expect this to change just given the time of year out west. But what I'd like to do is I want to step you down a little deeper. So this is the top 4 inches. This is the top 40 centimeters or 16 inches. So we start to kind of unveil the areas that have the longer standing profile issues with respect to water here. And if we go from there down to 100 centimeters, which is roughly 40 inches, this is just a substantially different map from where we were a year ago in terms of how much moisture is in the soil, especially here across the Western Corn Belt and the Great Lakes states. We are saturated farther to the south, and this is an area that I'm going to be very concerned about for a while because we've begun hurricane season. And any would-be tropical system, and no, we don't have one to talk about just yet, but if a tropical system were to come into this area, that rain would fall on saturated ground and cause problems. So these next 2 maps, I kind of want everybody just to remember, because this morning I went out and I grabbed some of the historical data from the European ERA 5 reanalysis data set. And what you're looking at here is volumetric soil moisture. So the numbers, remember, completely saturated ground, when you're looking at volumetric soil moisture, has a value of 50%. So I make that my top color. And what we're looking at first here is May of 2020. This was a year ago. Now, why I'm doing this is because here we are into the first couple of weeks of the month of June. And if we go back to what we were at the end of May last year and compare it to where we are now, well, the story starts to kind of show up here. So this is May a year ago, and this is where we currently are. So a year ago, going into summer, we actually had a pretty good profile of moisture, right, across much of the United States. We don't expect it to be high here, but especially right in through this area. So again, this was last year, and this is where we're going to be by the time we get to this upcoming weekend. And my biggest concern here is that regions that maybe aren't in full-blown drought right now are going to be very susceptible to it should it get hot and dry, whereas we're very wet south of this line, and thankfully recently brought up the moisture here and will continue to do so over in the Carolinas. I'll show you that in just a few moments. Another way to look at this is just to use this really cool feature that is a part of the drought monitor. What you're looking at is the latest drought monitor, which was released last week, and I'm going to go show you what things look like on June 2nd in 2020. So this is current, and this is a year ago. So quite a big difference between last year at this time, which is what you're seeing here, and this year. And so this just kind of starts to get us concerned about where we're going. And at the end of this video, I've got some analysis of some of the new long-range data. And I think we need to get to that pretty quickly here. So over the last 7 days, these have been life-saving rains here over in parts of the Carolinas. Some of the crop here, I saw some pictures where it was just devastated before this rain came through and really helped it revive. Then we had this large cutoff low that had been sitting here over parts of Texas and Oklahoma. Then it moved through parts of Arkansas, Louisiana, and today it's trying to move its way slowly through parts of the Tennessee Valley into the Ohio Valley. And it has spread rain relatively far to the north, but just keeps raining over very saturated ground. Now, just a comment about the rains that you see here in North Dakota and even back into Montana. Yes, great to see precipitation in this area. but it was one of those scenarios where not everybody got heavy rains, and with the winds and heat that came with this, we did see higher evaporation rates, really just robbing the ground of what it got from this. Okay. From there, let's take a look at what we got in the near term. So this is going to go backwards first. So we're just looking here at, let's go all the way back to sunrise. There we go. And we can see that cutoff low moving its way slowly to the east, and all of this convection around it. Some of these storms popping here, producing widely scattered showers and storms, are giving some folks plenty of rain. I'm going to watch this carefully. This is an MCS, a mesoscale convective system that has moved into parts of eastern Texas. And some of the models are taking the remnants of this and pulling it right up here through parts of southern Illinois. But the feature that I think is most important for the northern plains is actually what you see right over here in the high cloud cover. So keep an eye on this as I go back and forth. That's the wave that's going to get kind of kicked out ahead of a bigger trough straight toward Wyoming, Montana, North Dakota, and into the Canadian Prairie. And the models do not agree on what it's going to do. But just remember, be sure to check out this website. It's one of my favorites, blitzertongue.org, and you can see all of those storms that are out ahead of that cutoff low. But also look at this MCS that's behind it. A lot of lightning here. And here we are. This is Dallas-Fort Worth, so we're almost here into parts of Arkansas, Louisiana, where those big storms are kind of rolling through. So we can certainly see all the lightning strikes from each of these. Now this was live at about 3:30 in the afternoon on Monday. So here's the issue we're going to be dealing with. I waited until I got the 12Z European model in, and this is the next 7 days of total accumulated precipitation. A couple things to highlight. Very dry in this pocket of the western Corn Belt. A lot of storms in the Canadian Prairie. And that MCS that was rolling through here is expected to do that in the European model. And we need to see if that's consistent with other models. But with high pressure parked off the coast, we're just going to keep pumping in moisture into the south and southeast and keeping that area quite stormy. Okay, from there, let's now go see what the 12Z GFS says. Entirely different scenario here. Again, this is the European, and this is the GFS. Now the GFS has a lot more precipitation here, and I'm going to show you what some of those differences are and why it's doing that. But it's a very, very different precipitation pattern between the two models. And the thing that they're both trying to understand and deal with is actually this little feature here. So you can see there's a short wave that's come around the base of a broader trough here. And what's going to happen is the broader trough is going to grab this short wave, I'll kind of circle it, and I don't know, for lack of a better term, fling it out ahead here. Meanwhile, here's our kind of cutoff low that's been cut off from the main flow to the north, and it's just going to meander slowly underneath the stronger flow, or I should say south of the stronger flow that's over the Canadian Prairie. Now this is the mid-levels of the atmosphere, and what you're going to find is that this trough that's off the west coast is likely going to be there for a while. And we're going to see a larger ridge retrograde and develop here in the, well, almost on about the 110th meridian, right into that area. So if I show you that, this is from the European model. Here's a little wave that gets kicked out, like Monday, Tuesday. See, it's just a little thing right here, but it could kick off a low in this area. And then later on this week, there's going to be another one right there. See it? And that's going to be coming through on Thursday night and eventually eject here into the northern plains as well. Now, I'm showing you the European model, but to be honest, both of the models, when you kind of just step back and look at it, have very similar features. And as we then go out, they both want to build in by next week a larger ridge centered here that it's expected to stick around through much of next week. And the pattern really gets going something like that in the models as we extend this out. And I'll show you the GFS in just a few moments. So today, we're going to watch this area down here for severe weather where we've already seen the storms come through. And then we're going to watch right up here late tonight for some of the strong to severe storms. And then tomorrow, it's going to be back up here in the high plains as that wave, which is right now over Southern California and the Baja, gets tossed up here coming through Wyoming. So this will be the area in which we're going to watch severe weather. But just as we thought, the mesoscale convective system here, that squall line, the remnants of it might go right like this, over Memphis and through Paducah and up here towards southern Illinois, almost to I-70. And I'm going to watch that very carefully as well, because several of the model runs keep, doing something with it. Are you ready? Watch this first. So first, I guess I should say, look at all the scattered storms out here. We saw that on satellite. But as we work our way through this evening, there goes the squall line. And it almost even forms what I think could be a mesoscale convective vortex. Now this is where you get these mesoscale lows that form sometimes on the remnants of a squall line. And as I rock back and forth, you'll see it right here going through Arkansas and then ending up somewhere here tomorrow and then through Illinois. See that? So I'm kind of rocking back and forth, but that's the first part. For those of you in the northern plains, we see possibility of storms tonight. We just discussed that, and those storms could be widely scattered, but possibly severe in this area. Now let's get past that and go out into Tuesday. That's when the wave shows up, and it could be bringing severe weather to Montana, western South Dakota, even into Nebraska. And the models push that through. But if you notice, at this point, the high-res models aren't bringing rain into the Red River Valley of the North. And meanwhile, this pocket of the eastern Corn Belt looks to stay relatively stormy and wet as well. So let's see this model battle play out. We're going to go to the lower resolution European and then the GFS. So through Monday into Tuesday and Wednesday, that's what the European's doing with that leftover feature late Tuesday night. And here we get into the day on Wednesday. And again, we just see the European hanging on tightly to that feature, bringing in some heavy rainfall right here. But all around it, just broad scale low pressure and therefore precipitation. But what I failed to talk about was, let's come back here to Tuesday afternoon. We just went backwards. There's Tuesday evening, overnight hours, Wednesday morning and afternoon. And if you notice, the European model takes this low and produces more precipitation farther to the north and less in through this area. Now keep note of that. As we go forward, what we continue to see throughout the week on Thursday is a lot of scattered showers and thunderstorms here. And then the next wave we talked about comes through on Thursday night into Montana, and then eventually here on Friday morning, afternoon, and evening, back up into parts of, Manitoba and Saskatchewan. And the European model takes all of that, and when you add up the entirety of the next week, this is, well, I'll show you what you get in a few minutes. Let's do GFS first, sorry. So same features. I want you to think about what's going on with this low pressure here first, though. So let's zoom back out, and here we go. So this is getting through the day today. And in fact, wait a second, I do have brand new model update here. Why don't we just switch over and get all that data? There we go. And now we're looking at it. And so this is now getting out to what's coming through on Monday night into Tuesday morning, afternoon, and evening. And here's what the GFS is doing with that first low. See it? A lot more precipitation there. Now that's round one. There's then a second round right here that it brings through Thursday night into Friday. I mean, both models are trying to produce low pressure, just the GFS is extracting a lot more moisture out of it. The GFS, by the way, does not have the feature cutting through Illinois, coming from here up through Illinois either, which I found interesting. So if we just play this on out, that's how we see things evolving over the next week. Now, let's get to those totals maps. So 12Z European model, we'll just play this on out through the weekend, and we'll stop right here at 1 week. So heavy rainfall right in through that area. Let me switch my drawing tool here. Right in through here, and then also cutting through this part of the Mid-South, but limiting the moisture in this area, heavier rain farther to the north. See that? Now, the GFS does this. Saturday, Sunday, I'm getting out there. Let's take it 168 hours. Much more rainfall here. Not as much through Illinois because it's not handling that MCS the same way. Similar picture in the eastern Corn Belt, and it's got a wet corridor in this area. So this is our battleground right here. And we're just going to have to now cast our way through it to see how this all shakes down over the next 48 hours or so. Beyond that, the models kind of agree that there'll be a ridge right in through here. I'm showing you the GFS ensemble. It's the latest I had. And the flow doing something like that. So there will be a trough that will develop here over the eastern part of the United States while the heat backs its way up to the west. I'm going to show you those temperatures in a few moments. But how about we first look at what the week 2 precipitation anomalies are going to be. 12Z European model. Well, with that ridge in place here and then northwest flow there, we're not yet fully into that summer pattern to really crank out the thunderstorms. So overall, the model picks up on a drier week 2, much wetter to the south. And we'll kind of talk about what's going on right here in just a few moments. But if you're down here, kind of zoom up there. Let's just take it back out again. If you're right down here, this area is expected to see quite a bit of shower and thunderstorm activity out into week 2 as well. Now, what I think will be interesting will be to see what happens with this feature here. Right now, the National Hurricane Center is giving this about a 20% chance of development, and some of the models want to take the moisture and eventually kind of pull it into the Gulf of Mexico. Will it develop out there? I have yet to know and understand what it's going to do. Some of the models do and others do not. But I can show you that the GFS also attempts to keep a lot of convection in the Gulf, whereas the Europeans spread that farther into the south and east, the GFS doesn't. It kind of keeps it on this quarter. So a complete reversal of the precipitation pattern here from the European. Let me show it to you. Here's the GFS, and there's the European. So our models are separated. Now, in terms of skill score, the European right now is sitting at about a 5% higher skill score in terms of matching the pattern than the GFS. And we just need to know that as we think about where this forecast is going. So why don't we take it to temperatures next, and then we'll finish with some long-range discussion. Cooler weather over the last 7 days here, while the heat built west and then has spread through the northern plains and into the northeast where records have been set in the northeast. But it's only been lately that that's happened. We've seen triple-digit heat in a lot of places. Well, the pattern has since evolved quite a bit. And when we think about what that's going to mean, we're going to continue to accumulate a lot of GDUs in this area. But down south, where we are in deficit in those growing degree units, we're going to continue to have a slow accumulation rate compared to normal. I'll show you the west in just a few moments because there's big changes coming there. Tuesday's high temperatures, so let's talk about tomorrow. We're still deep into the 90s here. And as we play this forward, you're going to see there's Wednesday's highs into Thursday and Friday. Now, if I stop it back here on Thursday, remember, this is when the second low, the bigger one's going to be coming through this area. So large warm sector, triple-digit heat running up here through the plains, but much cooler in the west. In fact, this morning in this part of Oregon, there were actually freeze warnings out for that area. Well, as we go out here toward the weekend, remember one thing we saw was that the models were attempting to kind of redevelop the ridge in this area. We see the warmer than average temperatures once again regain kind of a foothold there and likely stick around. This is the 12Z European model, day 5 through 10. So we're getting all the way out there to the 17th. And the model's really trying to keep a lot of the heat in the Canadian prairie in the northern plains, but really anchored here in the west. The cooler region will be down south, according to the European, where there's going to be expected to be a lot of thunderstorms. Okay. From there, let's just look at what the long-range models say. This is June 12th through July the 12th. And if you notice, the models are trying to keep the same places with above average temperatures that are currently forecast to have above average temperatures through the next 15 days. It's kind of just keeping the pattern around. In other words, the long-range forecast from the European from June 12th to July 12th isn't breaking away from what it currently has. So it should come as no surprise that if it's not showing any sort of pattern deviation, that this is what the precipitation pattern looks like out to July the 12th. Better storms east, drier in this area. Why? Because it's trying to put a ridge here. And that would be exactly what we'd expect. Now, all this moisture to the east is because the same model is attempting over the next 30 days to keep a very strong subtropical high here. And the flow around this high just comes in like that and pumps in the moisture. This is a low-level subtropical high. So thinking about all of that, let's just see what other factors there are at play. In the near term, the MJO is collapsing back into null space, and we need to watch it carefully to see where it emerges. Does it come out over the Indian Ocean or closer to Australia? And then does it quickly move into the Western Pacific? And why I'm concerned about that is because the new seasonal forecasts were released. I had a special report that came out on early Sunday morning talking about this, but I wanted to show you that the long-range forecast for June, July, August looks to be on a wash, rinse, repeat, doesn't it? The same area that we saw showing up dry in the near term, well, the models are not pushing that dryness out, and it's trying to keep it stormy farther to the south. What I see when I get this kind of information is there's a lot of models spread, and therefore the models haven't honed in on a pattern just yet. And as a consequence of that, it's going to be very challenging for the models to predict any sort of a pattern break. But could I add any credibility to this? Well, let's look at temperatures first. This is June, July, August. Notice it's warm exactly where we're forecasting to be warm over the next 10 to 15 days. Again, not picking up on that longer term pattern. And if I showed you the pressure field, you probably wouldn't be surprised to see the high is still here and higher than normal heights or pressure here as well, which just keeps pumping in that moisture. Now I look at all of that and just start to ask some questions about maybe the validity of this. And then I blow it out to an equatorial view and I say, show me those upper level heights. And what I want to know is there any chance of developing that triple ridge system which sends the midsection of the country into drought? We do see right now that June, July, August, that the models are attempting to put the ridge at about the 105th meridian. If it was over the 95th meridian, the Corn Belt would be done. If it was over the 115th, then the West would be very, very hot. So let's have a discussion about this now that we've seen the model output. I'm going to focus here on the upper Midwest, and the reason why is because that's an area that we see in the near term there's going to be a bit of a model battle. But what we're going to discuss applies to the whole country. You see, when we look at the upper Midwest and we look at the June through August precipitation amounts, going back to 1895, we can see that year-on-year variability is high. Now, over the last 30 years, there's actually been a slight downward trend, but most of that is because 1993, we set all-time records with the total amount of precipitation, and that was the flood year. If you remove this 1 year, the precipitation trend is actually slightly up over the last 30 years in the upper Midwest for June, July, and August. But is there any chance it could be, one of these down years like 76, 88, 2003, or 2012, right? Is there a chance that we could be on the bottom side of this? So to answer that, I want to talk about a couple things we've been updating. The Pacific Meridional mode. New data came out for May. It's currently sitting right down here in its value, and that is about 2.5 to 3 standard deviations below mean, which means the cooler water that is off the coast here and the warm water farther to the north, this is a substantial signal and it's been around for a while. If I show you the latest ocean temperatures, you can see we still have some cooler water in the Gulf of Alaska, but not much has changed here. And I got asked earlier today, is it going to stay like that? Well, don't forget, the specific heat of water is 5 times greater than it is for land, which means these water temperatures just don't change overnight. They take several days, if not weeks, to change. It took a long time to end that La Nina, even though we pumped in a bunch of warm water here. So with this feature, what I did was I went back and I took those June through August time periods for the upper Midwest that were the driest. You see the years right down here. And it typically had cool water in the Gulf of Alaska and off the Baja of California with large blob of warm water here. Sorry for the non-technical term, but big area of warm water. I'll say this, the cooler water did extend back toward Japan as well. Now, do we have that this year? Let's go take a look here. There it is. No, we don't. We have the cooler water that's still a little bit here, but this is the most dominant signal. From there, knowing that it really would help to have all of this be cold to have a high risk of drought here. Let's go take a look at what else happens. You see, during these June through August years, we had the triple ridge, 1, 2, and 3. So the jet stream went over this, under that, over this, and then again here. And what that did was this high over low pattern shut down the moisture transport farther to the north. I don't see this fully forming yet. I don't see a big ridge setting up right here. In other words, I don't expect this June through August time period to make it into my top 10 list here. But there are some signs that there could be problems. Namely, if that MJO pops out back here over the maritime continent. Because during these summers, we tended to have a lot of rising motion here, which resulted in better subsidence there. So when we boil this all down, I'm going to take you back to those European model long-range forecasts. And what I'm going to do is I'm going to come back here to the United States and I'm going to show you the precipitation pattern first. What I'm concerned about this summer is west of the Mississippi River into this area. I think this is our region of greatest drought concern. You can see it in the models. We saw it in the ocean temperatures, but to be honest, I think the most important map to examine were these maps back here. Because a year ago in May, it looked like this, and this year it now looks like that in terms of volumetric soil content. And you get down there deep in that soil, and we just have risk that if we don't continue to get rain, that's going to be an area that is going to have quickly evolving drought. And that's the thing I wanted to share with you today, all right? Appreciate your attention. Had a bit of a longer video here, but that's what we're watching carefully. Thank you.